everyone. This is a video tutorial to help you understand how to draw a Newman projection. So let's take a look at this example. It says, draw the anti, gauche, and eclipsed Newman projections for the C3 and C4 bond in pentane. So in a Newman projection, we're going to focus on a particular bond in a bigger compound. We're interested with how the free rotation around a single bond is impacted by the substituents on those particular carbons. So the first thing we want to do is actually draw the line structure for pentane. So that is an alkane with 5 carbons. So I'm going to label our carbons 1, 2, 3, 4, and 5. And we are focusing on this section here, so that's where all the pertinent information will come from. So the first one we're going to draw is the antide conformation. The antide conformation is a type of staggered conformer. So what we do is draw a circle, and then we draw a line that segments into 3 separate areas, and then directly behind it we're going to draw 3 more line segments. So what this represents is, at this point right here, this is always the first carbon in the bond that we're looking at. So because we're looking at C3 and C4, this here would be the 3rd carbon. These lines here represent the various substituents that are attached to that carbon. So if I look at number 3, it would have 2 hydrogens attached to it, and it would also have this ethyl group coming off of it. So I'm going to add that information to these points. So over here, I'll put the ethyl. And it doesn't matter where you put it, that's just where I happen to choose. And on the other 2 points here, we'll put the hydrogen. Now we're worried about the C4 carbon. This can be a little bit difficult to visualize, but what you're supposed to see is that directly behind this 3rd carbon, there's the 4th. And these are the 3 substituents coming off of that 4th position. So over here on the 4th position, we have our 2 hydrogens placed here. And then we're going to place the methyl here. Now in this case, I did specifically place the methyl in this location because we're drawing the anti-conformer. In the anti-conformer, the biggest and bulkiest groups are going to be placed 180 degrees away from each other. This leads to the most stable conformer. So that means in a question, there are 2 ways they could ask you to draw an anti-conformer. They could either say, draw the anti-conformer, or they could say, draw the conformer that has the lowest energy, and that would be the anti-staggered version. Let's take a look at how we would draw the gauche. Okay, so let's take a look at how we would draw a gauche Newman projection. So gauche is similar to anti in that it is another type of staggered conformer, but it is slightly higher in energy, and we'll see why. So just the same way as with the anti, you first start with your circle, and then you're going to draw 3 lines to represent the 3 substituents on the front, and then 3 lines for the 3 substituents on the back. This here is still going to be the 3rd position, or the 3rd carbon. So what we're going to do is attach the substituents that are on that carbon position. So just as before, we have our ethyl group, and we have 2 hydrogens. Now on the 4th position, we're going to have the same substituents, but the way we place them will change. In the anti, these 2 are going to be the biggest bulky groups, and they're 180 degrees apart from each other. In the gauche case, however, they're going to be 60 degrees from one another. So I'm going to put a methyl here. It doesn't matter if I chose it here or here, I just did it because I prefer writing the CH3 in this spot. We'll also add the hydrogens in these locations here. So there would be 2 ways you could draw the gauche, one with this group next to this group on this side, or with this group next to that group on this side. Either one is fine. Now this is going to be higher energy because the big electron clouds with the ethyl and the big electron cloud with the methyl group are closer to each other, so you're going to have some repulsive forces that are felt. And whenever repulsive forces between electrons goes up, so does the energy. Let's take a look at the anti-conformer. Okay, so let's try and draw out the eclipsed conformer. So the eclipsed conformer is going to have a different initial presentation than the anti and gauche, and that's because anti and gauche are staggered, but eclipsed is its own distinct type of Newman projection. They do start out the same way though. So you are going to draw a circle, and then the 3 lines for the 3 substituents attached to that front carbon. This front carbon here is still going to be the C3 position. The difference is, in the eclipsed case, the substituents on the 3 are directly in front of the substituents on the 4th carbon. That'd be a little bit difficult to show in a drawing, so what we're going to do is slightly tilt the axis a little bit so that the substituents behind peek out. Now, just as before, on the third position, we're going to attach our substituents. So we have an ethyl group and 2 hydrogens. I did move the location of the ethyl group, but that's just because it'll lead to a cleaner drawing. Now we're going to add the substituents on the 4th position. So although there are not 2 distinct names, there are 2 types of eclipses that we could form here. The first one will be much higher energy than the second. So if on an exam you were asked to draw the highest energy conformer, what you're going to do is place the bulkiest group on the 3 directly in front of the bulkiest group on the 4th position. So on the 4th position, that is our methyl group and the 2 hydrogens here. So this is the highest energy eclipse conformer that we could draw. You could draw one that was slightly lower in energy, that would have the same initial presentation. The carbon up front, still here, representing C3, and we can still attach our substituents. And then we're once again going to draw our slightly tilted axis. So now what I can do is I will put the bulkiest group with the hydrogen. Because there's not going to be as much steric bumping happening, these two will not have as high an energy repulsion as these two would. And then I'll put in the other 2 groups. So this would be a lower energy eclipse conformer. The eclipse conformers, however, will always be higher in energy than the gauche or the anti-conformer. So that's how you draw an anti, a gauche, and eclipse conformers.